All right, so in our last video of Chapter 8, we're going to be working on rational inequalities. We did the rational equations. Now we're going to be working on the inequalities. So these ones are a little bit more complicated. So I'm going to give you guys a step-by-step that you'll be able to follow. So first step of solving rational equalities is this. You're going to state any domain restrictions that you have. Okay, so state any domain restrictions that your inequality is going to have. And remember, the only restrictions that our domain has is anywhere where any of the denominators would be equal to 0. So in each of these pieces, we tend to have multiple denominators. So anywhere that any of the denominators would be 0 would be excluded from your domain. Step 2, you're going to solve what we call the related equation. So the related equation just means replacing the inequality with an equal sign and then solving that. Okay, and that's going to be the same steps, the same strategy that you guys used yesterday in the video. Number 3, we're going to use these values. So whatever values you came up with from step 1 and step 2, you're going to use these values to divide a number line into intervals. Okay, so divide up a number line into intervals, and then once you have your intervals, you're going to test a value in each interval. So we've done this before. We did it with quadratic inequalities. So we're doing that number line true-false check. So test a value in each interval. With a true-false check. Okay, so solve each inequality. Let's run through step by step. So step 1 is we're going to state any domain restrictions. So if we set the denominators equal to 0, okay, so setting the denominators equal to 0, we're going to get our domain restrictions. So that's our first domain restriction. That just says x equals 0. Here we would divide both sides by 5, and so we still get x equals 0. 3 doesn't equal 0. That's not a thing, so that isn't going to be part of our domain restriction. So we have the same domain restriction here. X just can't be equal to 0. So we've got step 1 down. Step 2, solve the related equation. So we're going to turn the inequality into an equation and solve it the same way we would yesterday. So what we do with these, remember, is we look for an LCD, and then we're going to multiply both sides by the LCD to clear everything out. So my LCD definitely needs to have an x, definitely needs to have a 5, needs to have an x, which I already have, and it needs to have a 3. All right, so my LCD turns out to be 15x. Okay, so 15x is what all of these things have in common if I were looking for the least common multiple. So remember, the way these work is I'm going to multiply everything on both sides of the equation by a 15x, and that will get distributed to all of my pieces. Okay, so first I have 5 over x, and I'm going to multiply that by a 15x, plus 6 over 5x, same thing with this one. And on the other side, I have a 2/3, and I'm multiplying that by 15x as well. So the canceling that's going to happen should cancel out all of our denominators. So here you'd see that this x would cancel with this x, and you'll see this 5 reduces the 15 down to 3, and this 3 reduces the 15 down to 5. Okay, so same process that you guys were doing yesterday. So now, whoops, I missed this x right here. So all of my denominators have canceled, and I can rewrite this equation. So my equation now becomes 5 times 15, which is 75, plus 6 times 3, which is 18, equals 2 times 5 times x, which is 10x. Okay, so all I would have to do is add these pieces together over on the left-hand side. So 75 plus 18 is 93, equals 10x. So I would divide both sides by 10, and I'll end up getting x equals 9.3. Okay, so I get that, and I have my domain restriction from the step up above. So I got step 1, step 2. Step 3 is that I'm going to use these values, so that's the step 3 up here, to divide a number line into intervals. So here's my number line, and I'm going to split it up. I've got 0 and I've got 9.3. So I just split my number line into 3 separate intervals. I have numbers smaller than 0, numbers between 0 and 9.3, and then numbers that are bigger than 9.3. Okay, so what I'm going to do is for step 4, I'm going to test a value in each interval. So my test values, and you can make your calculator do this for you, and I'm going to show you how. So test value. On interval 1, I just need something smaller than 0. So let's use, interval 1. Let's use a -1. Why not? So plug in a -1, and so it's going to work like this. So I will take -1 and store it in as x. And remember, you hit Control before hitting this button to store. Store that in as x, hit Enter, and then you're just going to type this inequality in and see if it comes out true or false. So a little fraction, 5 over x, plus, and then I'll have 6 over 5x, and then my inequality symbols, see where the equal sign is over here? Hit the blue button first and you'll get all your inequalities that way. So there's the greater than and 2/3. Okay, so hit Enter, and it turns out it's false. Okay, so when I checked -1, it came out to be false. So I can put a false right here on this interval. So now pick something else. On interval 2, I'm going to select, how about 4? Anything you want, literally any number you want that's in here. So now I'm going to take 4 and store that in as x instead. And I'll copy and paste this inequality to see if 4 makes it true or false. Right? Enter, 4 makes it true. So that means that anything on that interval would have made it true. And then finally, on that last interval, I'm going to pick anything that's bigger than 9.3. So like 10 would be an easy answer, but you could also use like 200 if you wanted to. Anything bigger than 9.3. So I'm going to take 10 and store that in as x, or like I said, anything you want. An arrow up, copy, paste, and that would be false. Okay, so on the other side, this turns out to be false. So your final answer would be an inequality like this. Okay, so I know I'm going to have a 3-piece inequality because that's what these are going to look like right here. 9.3, like that. Okay, so now I know x can't equal 0 because that's part of my domain restrictions. That's definitely doesn't have the or equal to. Now this would have the or equal to if this did. And it doesn't. So my final answer doesn't. That would be my final answer, is just the region that ends up being true. Okay, so now that we got this process down, let's take a look at the next one. Number 1 is we list our domain restrictions. So we take all of our denominators and see where they're equal to 0. Okay, so here if I divided both sides by 3, I would get k equals 0 as my domain restriction. Here if I divided by 9, I would also get k equals 0, which I already have, so I don't need to list it again. And 3 can't equal 0, so that last denominator won't give me a domain restriction. Step 2 is I'm going to solve what we call the related equation. So I'm just going to take the equation and replace the inequality with an equal sign, like that. Okay, so this one is actually fairly similar to the one up above. When we're looking for an LCD, we got to make sure it has all of these pieces. So it needs to have a 3, and it needs to have a k, and it needs to have a 9. Remember, 9 breaks down to 3 times 3. So we already have a 3, so we just need to multiply in another copy of 3. And we already have a k, so I don't need another one. And with this denominator, I already have a 3, so I don't need another one. So my LCD is a 9k. So just like up above, I'm going to multiply both sides of this equation by the LCD, which is a 9k. And on the left-hand side, you got to make sure you distribute that LCD. So the first term gets multiplied by the LCD. Second term gets multiplied by the LCD. And then that other piece on the right-hand side of the equation also gets multiplied by the LCD. So remember, just like up above, if this step was done right, all of my denominators should cancel. So here the k's will cancel, and this 3 will reduce this down to 3. This 9k totally cancels, and this 3 reduces the 9 down to 3. Okay, so that's where I'm at so far. Let's rewrite, see what we got left over. Here all I have left is a 1 times 3, so that's 3, plus this is just a 2, equals, and I have 2 times 3 times k, so that is a 6k. So my left-hand side is now 5, and if I divide both sides of the equation by 6, I end up with k equals 5 over 6. Okay, so I'm taking this number from step 2 and this number from step 1. And in step 3, I will split up my number line using those numbers. Okay, so finally step 4, I'm going to do 3 different test values. So for my tests, I have 3 intervals. Interval 1, so something smaller than 0. Anything you want. I'm going to use -7. Interval 2, something between 0 and 5/6. So 5/6 we know is less than 1. It's about 0.6 something. So let's use 0.1. That way we guarantee we're a little bit bigger than 0, but it won't be big enough to be over this line. And then in interval 2, anything we want that's bigger than 5/6. So let's use the number 5. Anything. Just trying to emphasize here, you can use any numbers that you want. So what I'm going to do, I am going to store in my first value, which I decided on a -7. I'm going to store that in as k. And then I'm going to type in the original inequality. So make sure you hit the blue button before division, and you can open up a fraction template like this. So 1/3k plus, and then same thing here, little fraction button, 2/9k is less than, so hit the blue key, then the equal sign, and you can get all of your inequalities. Just like that. And fraction button one more time for the 2/3. So a little true-false check. This turns out to be true. Oops, you can't see it. There we go. This turns out to be true in interval 1. Now I decided on 0.1 for my next test value. So I'm going to plug in 0.1 and store that in as k instead. And then I will arrow up, copy, paste, hit enter. That middle one turns out to be false. And finally I chose 5 for this third interval right here. So 5, store that in as k, and I will copy, paste, and I get a true. Okay, so this region over here turns out to be true. So for your final answer, we actually have 2 different regions here. Okay, so 2 different regions. This one's anything smaller than 0. So my final answer would be any values of k that are less than 0, or, and then we have a separate inequality for this one, any values of k that are greater than 5/6. Okay, so this is a domain restriction, so I know I for sure can't equal 0. So this does not have the or equal to. And then this part, since it comes from step 2, this would have the or equal to if my original had the or equal to, but it doesn't. So I just leave my final answer like that. Okay, so that's 8.6b.